Today we're writing equations in point-slope form. And just like the name of this form indicates, you would want to use this form when you have one point on your line and the slope of your line. So here we're being asked to write an equation for a line with a slope of 1/2, which passes through the point 2, 3. So let's take a look at what information we have. We know the slope is 1/2. We know that one point that this line passes through is 2, 3. We usually need a second point, and in this case we don't have one, so I'm just going to call that second point x, y. So when we're finding the slope of a line, we use this formula. To find the slope, we take the y from point 2 minus the y from point 1 to find our rise, and the x from point 2 minus the x from point 1 to find our run. So let's substitute in what we have here. We know the slope is 1/2. We know the y from point 1 is 3, and we know the x from point 1 is 2. Okay? From here, we can simplify this a little bit to get rid of this denominator here. I'm going to multiply this side by x minus 2. It's the opposite of dividing by x minus 2. And I'm going to multiply this side by x minus 2, because whatever I do to one side, I have to do to the other. So I end up with y minus 3, and that equals my slope times x minus 2. So I haven't changed anything in my equation here. I've just switched the order around a little bit, and this corresponds to what we call point-slope form. A y minus the coordinate for the first point, y1, equals my slope times the quantity x minus the x value for point 1. And a linear equation that's written in this form, y minus y1 equals m times the quantity x minus x1, is in what we call point-slope form. And the line passes through this point, x1, y1, and the slope of the line is equal to the value m. So let's actually try to write some equations in point-slope form with different given information. So in this first problem, we're given a point and we're given the slope. So our point-slope form says we're going to do y minus our y value, which in this case is 3, and that's going to equal our slope times x minus the x value of our point, which here is -8. And I can simplify this one just a little bit. Y minus 3 equals 1/4 x plus 8. All right, let's take a look at this one. This time we're given 2 points. To write something in point-slope form, I need one point and I need the slope. Okay, so I'm going to try to find the slope using these 2 points. So this is going to be my point 1 and my point 2. So I'm going to take my y from point 2 minus my y from point 1, and my x from point 2 minus my x from point 1, and I get -4/2 or -2 for my slope. So when I go to write my equation in point-slope form, I'm going to pick this point to use as my point. Y minus 2 equals my slope times x minus 1. I could also have chosen this point and written my equation with that point. Would have worked also. All right, here's another one where I'm actually being given 2 points. This point, the function with input 4 equals -2, can also be written as 4, -2. And the function with input 8 equals 4 can be written as 8, 4. So I can go ahead and find my slope using these 2 points. 4 minus -2, my 2 y values being subtracted, and 8 minus 4. So I get 6/4, or 3/2. So y minus, I'm going to use this one this time as my point, -2 equals 3/2 times x minus 4. And I'm going to do a little simplifying here and make it y plus 2 equals 3/2 x minus 4. Okay, let's look at a word problem here. The student council is ordering customized foam fingers to promote school spirit. The table shows the cost of ordering different numbers of the foam hands. Can the situation be modeled by a linear equation? Explain. If possible, they want us to write a linear model that represents the cost as a function of the number of foam hands. Okay, so if we buy 4 foam hands, it's costing us $34. 6 foam hands is costing us $46. 8 is costing us $58. 10 is $70, and 12 is $82. So first we want to see, is this going to be linear? Do we have a constant rate of change? So as I look at my number of foam hands, they're all going up by 2 each time. And that stays consistent across all of these values. They're always going up by 2. So I do have a constant rate for the number of foam hands. Now going here, I also see they're going up. This time, they're always going up by a constant rate of 12. But we do have a constant rate of change for our x and our y, so I know this is going to be linear. So I am going to be able to write it as a linear equation. So I'm going to just pick 2 of these points here so that I can find a slope. So I'm going to subtract my y values, 46 minus 34, and my x values, 6 minus 4, and I get 12 over 2, or a slope of 6. Now, to write an equation, I need this slope and 1 point. So I'm just going to pick this first point. So y minus 34 equals 6 times x minus 4. And now I have written an equation to represent this situation.